For section 6.5, we are going to compare linear functions. And to start off with, we have Joe's Plumbing and Mark's Plumbing that have different ways of charging their customers. The function defined by J of t equals 40t represents the total amount in dollars that Joe's Plumbing charges for t hours of work. So it's called J because it's Joe's Plumbing, and then T is our hours, our time. And we would just simply multiply however long Joe works by 40 to represent how much he's going to charge. Then Mark's plumbing service charges $40 per hour plus a $25 trip charge. So his customers have to pay $25 no matter what for him to come out, and then they have to pay $40 per hour. So to compare these, let's see, we have to fill out the tables and get our ordered pairs. So for 1 hour at Joe's Plumbing, we are going to do 40 times 1, and that would be 40. So for 1 hour, we would pay $40. For 2 hours, we would do 40 times 2, so that would be 80. So my ordered pair is $280. And for 3 hours, that would be $120. And our ordered pair would be $120. Over here, for Mark's, we would have to do 40 times 1, which is 40. And then we would add 25, so we would have a total of 65. So the ordered pair is 165. For 2 hours, we would do 40 times 2, which is 80. And then we would add 25 to 80, so we would have 105. So for 2 hours, Mark would charge $105. And then for 3 hours, 40 times 3 is 120. 120 plus 25 is 145. So our ordered pair would be 145. So, oops, trying to get everything in there. What domain values for the functions j of t and for m of t are reasonable in this context? And explain. So remember, domain values are x values. So x here is really t for hours or time. And they want to know what is reasonable in the context of this problem. Well, we definitely don't want to use negative numbers because Joe and Mark are not going to work negative hours. That just doesn't make sense here in the context of this problem. So what values are reasonable? Positive numbers are reasonable. We could have fractions because if you think about it, the plumber could work for an hour and a half or 2¼ hours. He's just not going to work for negative 2¼ hours. All right, and then for the next part, we have to graph these for all appropriate domains. So that just means we're not going to graph any negatives. So we're going to have just the first quadrant for our graph. So the x, or the t in this case, is hours. So 1, 2, 3, 4. And then looking at our y values, or our out of our ordered pairs, we have to go up to 145. So I think what I'm going to do is, because I only have a small amount of space, I'm going to try and go by 25s. And then we're going to have to plot. So I'm going to change the color here, and then I'm going to change the size. So for Joe, we have 0, 0. We have 140. We have 2 and 80. We have 3 and 120. So Oh, trying to draw a straight line. Something like that. Then I'm going to change the color for Mark's, and he starts at 0.25. So he's going to start here, and then 165, 2, 105, and 3, 145. So as you can see, he is $25 higher, and that raises his graph up a little bit higher on the price scale there for each ordered pair. So compare the graph. How are they alike and how are they different? Well, they're alike because they're both linear. How are they different? They have a different y intercept. Their slopes are the same because they both charged $40 an hour. How else are they different? If they have a different y-intercept, one's going to be up higher or down lower than the other one. So that kind of takes care of that. So I think that's really the only way that we can say that they're different at this point. And having the different y-intercept is just having that extra charge for driving to the place where they need to fix the plumbing. All right, so now we are given the functions f of x and g of x, and we're told they're linear functions. The domain of each function is the set of all real numbers x such that 4 is less than or equal to x and x is less than or equal to 7. So basically what that means is that we can only use x values between 4 and 7. And both of those inequality symbols are underlined, so that means we can use 4 and 7. The table shows some ordered pairs that belong to f of x. So I'm going to label that. This is f of x. And it says the function g of x is defined by the rule 2x plus 3. So find the initial value and the range of each function. The initial value is where each function starts. And it told us that the smallest x value has to be 4. It gave us that in the paragraph up above. So the f of x function has an initial value of 8. It's what is the y value when x is 4 or when x is that smallest value. So the initial value for this one is 8. Now g of x is 2x plus 3. We're going to actually have to plug in the 4 here. So 2 times 4 is 8, plus 3 is 11. So the initial value of g of x is 11. So that takes care of the initial values for both. And then it says find the range of each function. Well, the initial value where it starts, we found that. Now we have to figure out where does it stop. So in other words, we have to figure out what is the y value when x is the largest number, which in this case is 7, because it told us between 4 and 7. So this one, f of x, is going to go to 14. So our smallest number is 8, and our largest number is 14. And we're talking about f of x. And we can say that f of x has to be between 8 and 14. So in other words, 8 is less than or equal to f of x, and f of x is less than or equal to 14. So the range or the y values are anywhere between 8 and 14 when the x values are between 4 and 7. We have to do the same thing for g of x here. We have to figure out what is the y value or the g of x value when x is 7. So we're going to do 2 times 7 plus 3. So that's 14 plus 3, so that's 17. So our initial value was 11. We're talking about g of x, and our largest value that it can go is 17 when x is 7. And again, it can be equal to one of those, so we can underline our inequality. So 11 is less than or equal to g of x, and g of x is less than or equal to 17. So quite a bit of answers there, but it just involves plugging in values into those equations and reading the table that was given. All right, so now we got to compare the following functions. A rainstorm in Atlanta lasted for 2.5 hours, during which time it rained at a steady rate of 1/2 inch per hour. The function a of t represents the amount of rain fell in t hours. The graph shows the amount of rain that fell during a rainstorm in Knoxville, k of t in inches, as a function of time t in hours. So they're using the same rates. One is a of t, and the other is k of t. So step 1, we have to write the rule for each one. So let's do Atlanta's first, and that's a of t, a for Atlanta. It said it lasted for 2.5 hours, during which time it rained at a steady rate of 1/2 inch per hour. So we're going to do 0.5 times t for hours. We have to say, because it only lasted for 2.5 hours, we have to say that the time is between 0 and 2.5. 2.5 is the largest number you can plug in because it didn't rain after 2.5 hours. And obviously it would start at 0 because we can't have negative hours of rain. So it has to start at 0. Now for the other one, the k of t, our y-intercept is at 0, so we don't need to write plus or minus anything. And then we just need to find our slope. So if we go up and then over from one point to the next, looks like we're going to go up 5 and over 2. So 5 over 2 times t is our slope, or sorry, our equation here. 5 over 2 is our slope. And this goes on the x-axis from 0 to 2. It stops at 2 on the x-axis there, the time value. All right, now we're going to compare the y-intercepts of the graphs of a of t and k of t. Well, the y-intercept, remember, is in mx plus b, and the y-intercept is that b value. Neither one of them have plus or minus at the end, so the y-intercepts of both is 0. So they're starting with 0 hours past, so starting at the exact minute, and then they're saying that there's 0 inches of rain when the rain started, which would make sense. At the time it starts, there's nothing. We have nothing to measure yet. We have to let some time pass and some rainfall before we actually have a measurement. So compare the y-intercepts. We can just say that they're both 0. They both are starting at 0 hours.